In the world of psychological and social science research, understanding how variables relate is paramount. Two essential methodologies, correlational research and quasi-experimental designs, allow researchers to investigate these relationships. This lesson is from Dr. Jennifer Francia Villanueva Damo and Dr. Hernie Pina Damo. However, they differ fundamentally in their ability to establish causality and the degree of control they have over variables. Understanding these differences, as emphasized in foundational methodology, is crucial for accurate interpretation of any study. Correlational research is a non-experimental method used to determine if a relationship exists between two or more variables without manipulating them. It is ideal when experimental manipulation is impossible, unethical, or impractical, such as studying the link between stress and heart disease. The main tool is the correlation coefficient, R, which quantifies the strength and direction of the relationship. It ranges from -1.0 to +1.0. A positive correlation, like +0.80, means both variables increase together. A negative correlation, like -0.75, means one variable increases as the other decreases. The primary limitation of correlational research is encapsulated in the famous phrase, "Correlation does not imply causation." This limitation stems from two major issues: the third variable problem, where an unknown factor influences both variables being studied, leading to misleading conclusions. A correlation between ice cream sales and drowning, for instance, is explained by the third variable, hot weather. The second issue is the directionality problem. It is unclear if variable A causes variable B, or if variable B causes variable A. For instance, does social isolation lead to depression, or does depression cause social isolation? Correlational studies alone cannot answer this. In contrast, quasi-experimental designs attempt to establish causal relationships but critically lack full experimental control. Unlike true experiments, quasi-experiments do not use random assignment to groups, often due to ethical or practical constraints, such as studying the effects of a specific educational program on existing classes. One common example is the non-equivalent groups design, where groups are formed based on pre-existing conditions, such as comparing students in two different schools. Another is the interrupted time series design, which takes multiple measurements before and after an intervention to analyze change. Because these studies often occur in natural settings, quasi-experiments boast high external validity, meaning their findings are often highly applicable to real-world populations. However, they are threatened by internal validity issues. Selection bias is a major concern, as the pre-existing groups may differ in ways that influence the results, making it difficult to attribute changes solely to the intervention. For example, comparing private versus public school achievement might reflect differences in socioeconomic status, not just the curriculum. To improve validity, researchers rely on advanced statistical techniques, like matching and propensity score analysis to control for pre-existing differences, reducing the impact of confounding variables. Despite their limitations, quasi-experimental and correlational designs are often the only ethical and practical options available. Researchers cannot ethically assign individuals to smoke cigarettes to study long-term health effects. They must rely on quasi-experiments comparing existing smokers and non-smokers. Similarly, in educational reform, randomly assigning students to radically different teaching methods is often impractical, requiring researchers to study naturally occurring groups while accounting for background differences. Both methodologies are valuable contributors to psychological and social science research. Correlational research helps to efficiently identify relationships and generate hypotheses. Quasi-experimental designs provide stronger causal evidence when the gold standard of true experimental control through randomization is simply not feasible. The choice of method ultimately depends on the specific research question, ethical constraints, and feasibility. Which research design do you find more challenging to conduct, correlational or quasi-experimental? Share your experiences and thoughts in the comments below. Like this video, subscribe for more in-depth methodology explainers, and hit the notification bell to master the science of research.